Alright, so we're going to see how to draw the Lewis structures, how to find the partial charges in bond dipoles, how to find the net molecular dipoles of each, and how many of these molecules are polar. Alright, so I'm going to explain how to do one of these Lewis structures, how to draw one of them. So we're going to do carbon tetrachloride. So you would draw each of the atoms, and then you would do the single bonds first to connect them. And then you will find how many valence electrons are in the molecule. So it's 7 for carbon, 7 valence electrons for chloride. And there's 4 of them. And then there's 4 electrons for carbon. So plus 4 equals 32. 32 electrons. Valence electrons. Alright, then you will give all the atoms an octet. So chlorine, and all the chlorines. Make sure that you're using up all the valence electrons. Alright, so it should, each atom should have a charge of 0, and what is it? And they all do. Alright, and then you could do that for the rest of these molecules. I already wrote them out. Okay, then we're gonna find the partial charges in the bond dipoles. So for this one, you will find the partial charges by seeing which atom is the most electronegative, and that one is chlorine. So you will put the partial negative charge on all of the chlorines. Alright, for this one, the most electronegative is the fluorine. So you'll put the negative charge on the fluorine. And then for this one, the most electronegative is the oxygen. You will put the partial negative on the oxygens. Put that one. Alright. And then for the O3, the partial negative will go into which one is the most electronegative, so that would be this one. And this one. This one would be partial charge plus. Alright, and this one, the most electronegative is carbon. So the partial negative will go on each carbon. And a partial positive will go on the beryllium. Alright, and then we're gonna determine the bond dipoles. So the bond dipoles work same way, kind of how the partial charges work. You have to point the arrow towards the most electronegative atom. So in this one, it's going to be chlorine. So the arrow is going to be facing right there. Here's a different pen. Facing right there towards the chlorine for all of them. And for this one, it's going to be fluorine. For this one, it's going to be oxygen. For this one, it's going to be this one. For this one is going to be chlorine. Alright. Alright, then we're going to try to find the net molecular dipoles of each one. With this one, you would do the molecular geometry. So this one is a tetrahedral. So the net dipole is going to be 0. Dipole is 0. And if you have a 0 net dipole, that means it has to be nonpolar. This one, molecular geometry is bent. So the net dipole is be going down. And that one is going to be just polar. The molecular geometry of this one is trigonoplanar. So the net dipole is 0. Net dipole is 0. 0, and it has to be nonpolar. Okay. This one is bent. So the net dipole is going to be pointing down. And that one has to be polar. And this one is also, it's linear, actually. So the net dipole is going to be 0. It's going to be 0. And that one has to be nonpolar. So to answer the question up here, how many of these molecules are polar? It's going to be O3. And it's going to be OF2. Alright, some common mistakes are that people would look at these arrows and try to find the net dipole. You have to look at the molecular geometry of each of these. That would give you the wrong answer. And another common mistake is that you need to count how many valence electrons in order to make each of these Lewis structures. Alright, that's it.